Hey, hello guys, welcome, vanakkam, vandanam, namaskaram. Today we are going to see part 2 of electric potential and capacitance. Okay, so yeah, we have already seen part 1 and this is going to be part 2 where we are going to proceed with the rest of the lesson, which is capacitance. Okay, so what is capacitance? In normal words, capacitance can be also said as it cannot be said as conductor, but it can be said as condenser. Okay, it can be said as condenser. Okay, condenser it can be said as, or it can be said as capacitance. Okay, see, normally in normal word, okay, in our normal world, okay, normally we will not use the word called as capacitance. We will be using the word called as condenser. If in case, for an example, your fan has stopped running, then the first thing that they will be checking is this condenser only. They'll be checking whether this condenser is working or it is not working. So in the fan there is condenser. In every electric body there will be condenser. Okay. So you will be first checking this condenser only, and it is represented by the letter C. It is represented by the letter C. Okay. In terms of symbol, if you want to represent it with in terms of symbol, then it can be represented like this. Okay, just like this it will be represented. It can be represented, or also in some places it can be represented like this. Okay, or in some places, mostly the condenser that we are using for our fan, right, it will be represented like this. Sorry, not zero. Okay, so just like this it will be represented. So what does it mean? What does it mean? Okay, you can exclude this one. This is not required. Only these two it's enough. Okay, this means just the normal condenser. Okay, this means just a normal condenser. Then what does it mean? It means variable condenser. So variable condenser, in sense, we will be having a regulator for fan, right, in order to change the speed of the fan. So that means it is varying. The speed of the fan is varying, and that is because fan is having variable conductor in it. Okay, or condenser in it. Variable condenser in it. So how does it actually work? How does this total system work? It works very simple, in a very simple way. Normally there will be circuit. Okay, see, there will be two plates kept. Just this one I'm drawing in a big way. And then charge will be given to one. Charge will be given to one plate. Then automatically what will be happening, if it is a positive charge, then it means it will be full of positive, 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 positive. Then this part will become negative, 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 negative. Okay, then it will be going here, it will be coming, and then here there will be battery. For battery, one big line and one small line has to be there. For a condenser, there is no such rule. Okay, just two equal parallel lines can be there, then it will be said as condenser. For a battery, it has to be one big line and one small line, where the big line represents the positive charge and the small line represents the negative charge. So this is what actually happening. This is what actually is happening. You want to give us some charge to it, then automatically it will be condenser. It will start to work. Okay. So flow of electrons takes place. Flow of electron takes place till the potential of two different points in a circuit becomes equal. So, because why flow of electrons takes place, why charges takes place, it is a 1 mark question and can be asked in your examination, that why does charges flow? It is because there is a difference in their potential energy. That is why there is a flow of charge. This is very basic concept only. So after this, now we are going to see the formula. We are going to see the derivation. Okay. You have to know this one thing. If charge is high, then automatically voltage will be also very high. If charge is high, then automatically voltage will be also very high. Actually, this voltage is there, right? Voltage, wait. If charge is high, then automatically voltage will be also very high. Okay, so if charge is high, then automatically voltage has to be high. So now what is actually voltage? Very basic question only, every one of you would have known. If someone is not having the basic idea, then I'll be just giving you a basic idea. Voltage is a sort of force, okay? That force is helping those electrons to move in a conductor so that those electrons will be doing work. So work like lighting a bulb or making a fan to rotate, like those things we can say. So if in case I'm saying that this is a conductor, this is a conductor, and this is another conductor. Okay, so this conductor is having less amount of charges only. So that means less amount of voltage is enough to just transport these electrons from one place to another place. But here, this is a conductor which has a lot of charge in it. That means to transport all the charges from this point, from this conductor to another place, we want a lot of voltage. That means we want a lot of force. So that is why if charge is high, okay, if charges are high, then automatically voltage will be also very high. So in order to remove the proportionality symbol, what we will be doing, we have to put a constant and we have to put equal to. So K is equal to CV. Okay, so K is equal to CV. So what is the C? C is what? Capacitance. C is what? Capacitance. C is what? Capacitance. Okay, it is me being lazy to write capacitance on board. Okay, so it means a capacitance, and this capacitance is dependent upon nature of material. Okay, so it is dependent upon nature of the material. Okay, so then C is equal to, then what is C equal to? C is equal to, okay, C is equal to Q by V. C is equal to Q by V. Okay, so C is equal to Q by V. Coming to the definition part, I can say the definition is the ratio, okay, the ratio of given charge, okay, of charge, okay, the ratio of charge, given to the conductor and the potential developed on it. Okay, see, the ratio of charge that is given to a conductor is given to a conductor and a potential developed on it. So, and the potential developed on it. Very simple, you can just say the ratio between charge and then the potential. Okay, so charge that is given to, see, this is what the conductor is. This is a conductor and then this is also a conductor. These two are conductors. Okay, and now you are actually giving charge to these two conductors. I hope this is visible diagram. If this is not visible, I can make it a little bit bigger. Okay, I can make it a little bit bigger like this. I will again make it small. So this is what the conductor is, and from here you are giving charge. Okay, from here you are giving charge to this one. So after giving charge to here, that means the charge is being developed. So if charge is being developed to a conductor, then automatically there will be some sort of potential, right? So that ratio between the charge and the potential is what known as capacitance. Okay, perfect. All set. So the SI unit is the part of SI unit. I can say it as Farad. Okay, the SI unit is going to be Farad. I know I'm just stuck in here and there. What can I do? I haven't yet even read. I'm just saying everything that I've listened in class. CGS and from notes. Okay, CGS unit is going to be stat Farad. Okay, stat Farad. So then what is the relationship between these two? So 1 farad is equal to 9 into 10 to the power of 11 stat farad. Okay, 9 into 10 to the power of 11 stat farad. So 1 farad is equal to, 96,500 coulombs. 96,500 coulombs. Practical units. So what are the practical units? See, this is a very large amount. If you know the usage of 96,500 coulombs, then you will be understanding that it is a very large amount of charge. So we will not be using this one. Instead of that, we will be using practical units such as microfarad, okay, microfarad, millifarad, and then centifarad. Centifarad, so nanofarad, not centifarad. There is no such thing as centifarad. Nanofarad. Okay, here it is 10 to the power of minus 6 into Faraday. Millifarad is 10 to the power of minus 3 into Farad. That means Farad F means this is what this amount is. Okay, so nanofarad is 10 to the power of minus 9 into Farad. This is what it actually means. Okay, now we will be doing one numerical. Before that, it will be very useful for us when we are revising or when we are making a one-shot video, when we will be covering the total chapter within one part, then it will be very useful for us to use it. Okay. Then the next thing is that Earth. Okay, Earth itself, we are considering Earth itself as a condenser. Earth itself is considered as a condenser. Okay, so C is equal to Q by V. C is equal to Q by V. So where V is equal to 1 by 4 pi epsilon naught into Q by R. Okay, if you don't know this formula, or if you don't know the formula's derivation, already we have done this derivation. You can just check it out. It's very easy, you know. Every time I say easy, it's really tough. Like that I won't say. If you understand, everything is easy, but for me everything is tough. Okay, so C is equal to Q whole divided by, if you just substitute this value over there, 1 by 4 pi epsilon naught into Q by R. So C is equal to Q into, so this will be 4 pi epsilon naught into R whole divided by Q. So this Q and this Q can be cancelled out. Then at last what you will be getting, you can get 4 pi epsilon naught into R. So what is R over here? Okay, see, R is actually none other than, if this is what Earth, and then this is what the center of mass of Earth. That means the geometrical center of Earth or geometrical center of joy is known as center of mass. We have studied in our center of mass lesson itself. So from this point to this point, okay, there will be some distance, right? That distance is what known as R. That is what this R is. So what is the distance of R? See, normally for sphere you can take this R. Okay, so for sphere you can take this R. So for our real world, okay, now we will be substituting values. By values, if you want values. Okay, by values. Now how will it be? It will be first 4 pi epsilon naught. What will be 4 pi epsilon naught? It will be 9 into 10 to the power of 9 into R will be 64,000 kilometers. So you can just convert it into meters. So 64,000 kilometers. If you want to convert it into meters, just multiply it with 10 to the power of 3. So into 10 to the power of 3. Okay, so if you, so here, actually it is 1 by, not just 1 by 4 pi epsilon naught is what actually known as 9 by 10 to the power of 9. Here it is just 4 pi epsilon naught. So here it will be 9 into 10 to the power of 9. Remember, okay, 1 by 4 pi epsilon naught is what is equal to 9 into 10 to the power of 9. Here it is actually, denominator it has to be 9 into 10 to the power of 9, because just 4 pi epsilon naught it is, not 1 by 4 pi epsilon naught. Okay, so this one, if you simplify these values, I've already calculated them. 7.11 into 10 to the power of minus 4 R you will be getting. Okay, minus 4 Yeah. Sorry, F for Faraday, not R. Sorry. Minus 4 farad you will be getting. Okay. See, I have given you practical units over there. Here I have given you practical units. I can use a millifarad. Okay, I can use millifarad. That means which will be 7.11 into 10 to the power of minus 1 mf. Okay, like this also I can represent it. So again, myself behaving like a cheapskate for space and putting it over here. Okay, so then the next concept that we have to discuss is dimensional analysis, dimensional formula. So what is it actually? We will just go through our knowledge itself. We know that C is equal to Q by V. So for Q we know that it is A into T. Okay, then for potential what is it? For potential I think see here when it is. For potential it is work done by charge. Okay, we will calculate again. Work done by charge. V it is work done by charge. Actually, I already know it's work done by charge, but I thought of just copying the values. It's okay, we will just work it out. So for work done, what it will be? It will be force into displacement, right? So for force, what it will be? Normally, I will be calculating it again and again. If you want, you can just skip it out. It will be mass into acceleration. For acceleration will be LT power minus 2. This will be m, and since we are having here also L, I can write it as just square over here. So it will be so for work done we have got. So for charge it will be AT. So for charge it will be AT. So this is what just like this itself you can keep, or I will be writing this as A power minus 1 T power minus 1. Okay, so for voltage we have got, for charge also we know, and we have the formula. So that means you can easily put it as AT whole divided by m L2 T power minus 2 A power minus 1 T power minus 1. Then it will be, if see here it is A inverse, if it goes to the numerator it will be A square, because here is also A. So A square, it will be T square. Here is also another T. So that means it will become as T cube. Okay. Then that means this I can cancel, this I can cancel. Remaining only two things are there. So m inverse 1 and L power minus 2. L power minus 2 m inverse T power 4. So we have made a mistake in calculating. Wow. Yeah, so it will be 3, and here also another one is there. Na? So it will be 4 here. Okay, it will be 4 over here. So this is what the formula is. Okay, don't feel bad whenever you are making a mistake, because now I'm kind of feeling bad for it. We all make mistakes. We all are humans. It's very normal to make mistakes. What's wrong in making mistake? Okay, so before going into the next topic, we'll be just seeing one basic concept that we have to know. It is that if there is a conductor, okay, if there is a conductor, these two are conductors. Since it's a basic concept, I'm going to rub it, just know it. So this is connected with a battery, which is negative charge, and then there is positive charge. Okay, so it will be all negative, 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 negative. It will be all positive, 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 positive. Okay, so here if it is all negative, actually it will be how it is. Yeah. Sorry, wait. I will be now saying you a story. Okay, so battery is connected. Now first charge is going. See, electricity will be going in a single direction. Okay. Actually, in our books, they have given exactly opposite the direction of electricity. That is, they have said that flow or the direction of current is opposite to the direction of electrons. Okay, it is because scientists have understood it wrongly that protons flow is what the positive charges flow is what they thought it is actually electricity, but it was quite opposite. It was the flow of negative charges. Okay, but in college textbooks they have changed it into flow of electrons itself. That is the direction. But in our school textbooks they haven't changed it. So it's your wish here. But in our examination in CBSE, you have to write it as it's the opposite direction to flow of electrons, because that is what given in our book, even though that is wrong. Okay, so see, this is what negative charge. Normally, it will be flowing like this only, from here to here only. It will be flowing like this direction only. It will be flowing, but we have to consider it as like this direction because of our NCT textbook. So we will also go in that way itself. Okay, so now it's flowing, it's flowing, it's flowing, it's flowing, and first it will be coming here only. First it will be coming there only. So it will be getting a positive charge over here because it is positive here. Okay, it has got its own positive charge over there. Now there is space between them. This is actually known as this is actually our space between them. There is no contact. We have already studied in our last lesson itself, electric field lesson itself, that induction method. By induction method, this will be getting negative charge over here. If it is getting a negative charge over here, then that means what? In a particle, if a particle, see, this is actually a conductor, and that conductor is actually neutral in nature. Now before charging this, it was neutral in nature. After giving this battery's connection, after giving the connection to the circuit of this battery, it has got negative charge in it. That means first it will be having positive negative, like this will be having, right? Now one side will be full of negative, another side will be full of positive. Okay, so what we are going to do is we are going to earthen this side alone. Okay, if this is what the two sides is. So this side it is actually full of negative, this side it is full of positive. So I'm going to earthen all these charges. Okay, I'm going to earthen all these charges. Okay, that means I'm going to remove all these charges. I'm going to remove all these charges. If I have removed them, okay, so now it is actually, it has got earthened. Actually, if I didn't earthen them, that means if they were like this itself, that means this positive charge is there, right? This positive charge will be increasing the potential of this one. Okay, this positive charge will be increasing the potential of this one, and then this one. This negative charge will be decreasing the potential of these two. How is potential energy normally defined? When you are taking one unit coulomb and when you are bringing it to the circuit against the force in sense against the repulsive force. Since it's positive, here also it is positive, here also it is positive, here also it is positive. There will be repulsive forces that will be acting against this charge, right? So against this, how much force is required to bring it inside this point is what said as voltage. Okay, the force is to bring this charge. That is what I have already said. So this is negative charge now, so there will be attractive force towards it. So this will be reducing the voltage. This will be reducing the voltage, but this will be increasing the voltage, and also this will be increasing the voltage. If I earthen it, that means if I am nullifying this total charge, so then that means only 2 points will be there to just push it away. To push it away, only two positive charges will be there. There are many positive charges. I'm just taking this as one positive charge, and I'm taking this as another positive charge. So that means automatically the voltage will be reduced. This is what the basic concept that I want to say. Very easy, right? Wait. Easy work. So now I'm going to consider some electric plates. Okay, some electric plates. Imagine this is an electric plate and it has positive charge in it. Okay, and then I'm going to put a plate here. That means here it is going to have negative charge by induction, and here it is going to have positive charge. I haven't earthened it yet. So there will be, if I'm placing another plate, then that means it will be negative charge, and here will be positive charge. Okay, like this it would have become. Okay, all clear, right? If you want to write the heading, what is the heading? Yeah, so it is parallel capacitance, I can say. Okay, or if two What is the heading? Okay. Principle of capacitor. Principle of capacitor. So it is actually principle of capacitor. I will make it here. Okay, so now what we are going to do is we are going to take two plates, okay, capacitance of parallel. Okay, we are going to take a parallel plate capacitor. So parallel plate capacitor, and then these two we are going to take. Okay, like this I'm going to take it. Okay, see there are two different plates now. I will write it, draw. I don't know why this page is giving me some ill effects. Just give me some time. Okay, so what I'm going to do is now first subtopic is going to be capacitance of parallel plate capacitor. Capacitance of parallel plate capacitor. What is the difference between capacitor and capacitance? Capacitance. The capacitance of a parallel plate capacitor. Capacitance is a nature. Okay, it is a nature, whereas capacitor is the material. So here is a plate. Here is a plate, which is positive charge. Okay, and it is negative charge. Okay, so we know that the field lines of negative charge will be inwards and field lines of positive charge will be outwards. Okay, this is a concept that we know, right? Okay, so how will be the charge here? It will be like this. Okay, so what will be the formula of electric field? Before that, this distance is known as d. Okay, so electric field is equal to sigma. Epsilon naught by sigma by epsilon naught. Sigma by epsilon naught. Sigma by epsilon naught. Okay, between two plates. If it is just a single plate, it will be sigma by 2 epsilon naught. This we know already. Okay, so sigma is equal to what is sigma? It is equal to Q by A. So if you substitute this formula, over here, E is equal to Q by A sigma epsilon naught. Okay, so this one is something that you should know for calculation purpose. Now, E is also equal to, we can also say that E is equal to voltage divided by distance. Okay, distance. When it is actually uniform electric field only, this formula can be applied. Other than that, you cannot apply this formula. Note the point, your honor. When it is uniform electric field only, you can apply this formula. Otherwise, you cannot apply this formula. Okay, so now it means electric field into distance is equal to voltage. Electric field into distance is equal to voltage. So what is electric field? We have this formula, right? So you can just put it over there. So it will be Q D whole divided by A epsilon naught is equal to V. Okay, so we have got this formula. So we know the formula of C, capacitance is equal to Q by V. Capacitance. What are we first? Yeah, I forgot to say that. What are we finding here? We are finding the capacitor of this plate. Okay, we are finding the capacitor of this plate, right? Okay. So we know the formula that C is equal to Q by V. We know the formula that C is equal to Q by V. So in this, Q is something that is defined in it, but we don't know what is V in it. We don't know what is voltage in it. So first we have to find the voltage. First, for finding voltage, we know that voltage is equal to electric field into distance. If the electric field is uniform in nature, if it is actually uniform electric field, then we will be using this formula. Okay, this is a known thing. So in this, distance is constant, but we don't know about electric field. Electric field will be varying. But we know that the electric field between two oppositely charged plates is equal to sigma by epsilon naught. And then sigma is equal to this formula we know, which is sigma is equal to Q by A. Lambda is equal to Q by S. Then sigma this and rho. Okay, rho is equal to Q by volume. Q by volume, this we know, right? So if you substitute, then at last you'll be getting this formula. This formula you'll be getting. So if this one you are placing in this formula, you'll be getting this one. Okay. So we have come till now. So just substitute in this place this V formula. So C is equal to Q whole divided by QD by A epsilon naught. So C is equal to Q by 1 into A epsilon naught by QD. Q can be cancelled out. At last, C is equal to A epsilon naught by D between two parallel capacitors. Between these two parallel capacitors, this is the formula. That means what? C is directly proportional to. Okay, if in case they are parallel, that means C is directly proportional to A, and then C is inversely proportional to D. C is inversely proportional to D. That's it. You have got this. Okay. Now we are going into the next concept. Actually, this is a 5 mark question. This can be asked as a 5 mark question, or this can be asked as the first division of the. This can be asked as the first division of 5 mark question. The second 5 mark question will be with. It will be with a dielectric. It will be with a dielectric. Okay. So capacitance with dielectric. That means what? See, here I've got a plate. Here also I've got a plate. Okay, in between I'm going to keep a dielectric. What is a dielectric? If you don't know, you can check in the last video like that. I can say, but I won't because it'll be taking time. Dielectric is a conductor. Sorry, is an insulator. Very sorry. Dielectric is an insulator which can form charges if you are rubbing on it. If this is an insulator, it can charge. It can form charge by rubbing on it. That is what we'll be saying it as dielectric. Okay, so this is K. This is positive, and then it is going to be negative. Okay, so here from positive to negative, it will be going like this. Like this, it will be going. Okay, so what have we seen the formula for without dielectric? Without dielectric, it will be capacitance is equal to Q whole divided by Q some. I forgot that within that. Okay, because I wasn't trying to by heart it. C is equal to epsilon naught A by D. Epsilon naught A by D. But if I can prove it again. But I haven't by heart the formula. Okay, so C is equal to A epsilon naught by D. C is equal to A epsilon naught by D. D is the distance of distance between these two, metals. Okay, or the conductors, and then A is what the area. Okay, A is what the area. That means this total area. We are talking about this total area, and then epsilon naught is what equal to 1. Epsilon naught is actually permittivity of air. Epsilon naught is what equal to permittivity of air. Okay, so I have to remember this. Okay, now I've got it into brain. Now I've got it into brain. This is something that we will be doing it for when it is kept in air. But when, what if, okay, this is actually for air. For air. Okay, for air, we will be using this one formula. Okay, so now what is it? See, just you can zoom it closely. I don't know whether it is visible for the camera. I just strongly recommend you all to zoom the video and also to watch the before video, which is electrostatics completely, so that you will know all these concepts very clearly. Okay, because these two chapters are completely interlinked. That they have said that these two are single chapter in MCQ point of view. That means in NEET point of view, they have just combined these two chapters into single concept known as electrostatics. Then just look how interdependent they both are, intradependent they both are. Okay, so you know this. Oh, okay, so till now it's all clear, right? Till now it's all clear. So that means there will be some, we are here trying to find the potential only. Okay, we are trying to find the potential only, because capacitance, if you take capacitance, is equal to Q by V. This is something we know, and Q is a charge that they will be giving you. Okay, we have to find only the voltage. We have to find only the voltage. So in that case, first we will be finding voltage in this case. Okay, voltage is what we have to find. Voltage total is equal to voltage which is in air, okay, voltage which is in air plus voltage which is in this dielectrics. Exactly right. So voltage in air. So I will be taking this thickness. Okay, this thickness can be concluded as what I will be taking it as T thickness, and in this total distance can be concluded as D. It will be concluded as D. Okay, so R, we know that 1 by 4 pi epsilon naught into, okay, into Q whole divided by D. Okay, so this is the place where a lot of people get wrong. D is, see, first you have to find only for R. So only for R, in sense it will be D minus T. It will be D minus T. Correct, right? It will be D minus T. Okay, this and for this one, okay, plus voltage in dielectrics in sense. So for dielectrics it will be 1 by 4 pi epsilon naught whole divided by into Q into T. Like this you can write. But since we have taken, okay, since we have taken, yeah, this is correct only. Okay, see, how have we taken here? We have used this formula now, so here also we are going to use the same formula. Here also we are going to use the same formula. That means electric field into D minus T, you have to multiply it. See here, what is E? E is equal to, at last we have got E is equal to Q by A epsilon naught. E is equal to Q by A epsilon naught, and C is equal to what? Q A whole. I'm forgetting it. Epsilon naught A by D. Epsilon naught A by D is what C that we have got. Okay, and E is something that we have got. Q by A epsilon naught, because E is equal to sigma by epsilon naught, and here it is just the distance. Okay, it is just the distance here. It is what the distance is. Here, what is sigma? Sigma is equal to Q by area. So here area is what? Area is this total distance I have said, which you can just multiply it with a D into D, like that also you can multiply. It depends. It depends upon the shape. Okay. So here it is actually area. Like this you can do it. here, if you want to put here E, in place of E, if you want to put sigma by epsilon naught, then that means with that, here the sigma is having what it is having? Q by area, right? So this area you have to exclude. From this area you have to exclude. Since we are discussing about area, you have to exclude this particular area. You have to exclude this particular area. For that you have to multiply with it d minus t. So for that you have to multiply d minus t with it. Okay. So for dielectrics, what you have to do? You have to include only this area. So it can be said as plus E into T. Okay, plus E into T, or E dash into T will be correct because electric field inside this will be kind of different and electric field outside will be different. Okay. So electric field inside and outside. So we know that E is equal to sigma by epsilon naught. So sigma whole divided by epsilon naught into d minus t plus here it is sigma by epsilon, just epsilon into t. Why it is just epsilon? Because it is a dielectric. Dielectric is a medium, and for medium we will not write epsilon naught. We will be writing epsilon only. Okay, so epsilon is equal to epsilon naught into epsilon r. We know this formula. Epsilon is equal to epsilon naught into epsilon r. Okay, so here it is sigma by epsilon naught into d minus t plus sigma by epsilon naught into epsilon r into t. Okay, so from this you can take common. What all can you take common? You can take a sigma by epsilon naught as common. So sigma by epsilon naught, which means d minus t plus t by epsilon r you can take as common. So this distance is something that you have to know. At last, we know that also epsilon r is equal to k. Epsilon r is equal to k. So simply I will be giving the formula that voltage is equal to this one. Okay. So capacitance in this place, if you are substituting this formula, I will take a different color so that it will be good in looking. So it is equal to q whole divided by this whole formula. In order to look and same, I'll be using red color, but I don't have pink color in this option. Okay, so C is equal to epsilon naught A whole divided by T minus D plus T whole divided by K, or also it can be said as epsilon naught. Okay, it can be also said as epsilon naught. When dielectric is present and also air is present, when dielectric is present and also when air is present, we will be using that epsilon naught by A. See, epsilon by A is always constant when there is parallel capacitors. Okay, when there are two parallel capacitors, it is always common and numerator that there will be epsilon naught by A. But the denominator is the thing. Okay, so in place of denominator, what you have to do is you have to substitute this value. That is d minus t plus t by k Okay, when both air and dielectrics is present, when only the air is present, then you can use this formula, which is epsilon naught by a whole divided by d. Okay, now what can we do completely? What can we do if this total capacitor is immersed? That means there is no air at all. Only dielectric is present. In that case, what you have to do is only dielectrics is there. Okay, in that case, what you have is first we will be taking this formula. That means it is completely in a medium, right? So that means epsilon will be coming by d. Okay, by d. It means epsilon will be coming. Epsilon is equal to epsilon naught into r. So if I can just substitute the value, that is epsilon naught into epsilon r a by d. Okay, so this value will be changing. So I can say that it is equal to k into C naught. Okay, C naught is what? Here this capacitance can be said as C naught. So that means you can just multiply the K value of this capacitance, which can mean that see K value is different for every material. For glass, it is from 5 to 10. Okay, for metals, it is infinite. For water, it is 81. For mica, it is 6. Like that, it will be differing. For air, it is 1. For air, or you can also take it as vacuum, it is 1. Okay, so this is something you have to know. Okay, so we are going to discuss another concept. So that we will be strong in polarizability. We have to discuss another concept. So I have taken a small break. Okay, now we are going to discuss into potential, dielectrics and potential. I have already said very clearly what is polar molecule, what is non-polar molecule. When we were in the before lesson in electric field, and in electric field itself, I have already said it. What is potential? Sorry, what is polar and what is non-polar molecules? I will be just giving you one short revision. A non-polar molecule will be having its positive and negative charges very close to each other. Okay, very close to each other. They will be said as it will be adjacent to each other. And a polar molecule will be having far away from each other. Just like in chemistry, polar solvent and non-polar solvent, where a polar solvent can be split into a positive and then into negative, but where a non-polar solvent or solute cannot be split into positive and then negative. It cannot happen. Organic substances are very good examples. Okay, so that is what non-polar and polar is. Yeah. Okay, we are going to discuss one concept before going into this. Okay, so also this will be okay. See, these two are dielectrics. Positive, 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 and then negative, 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 negative. Like this will be, yeah. And then there will be a dielectric. There will be a dielectric that is kept. So that means not this much, it will be. I'll take it as this much. Okay. So here positive charge will start to by induction. Okay, dielectric means what? It is an insulator. By rubbing, it will be getting charges. So we have rubbed and we have kept it there, and it has got its own charge. Electric fields here will be like this, and inside will be like this. And always remember this one point, that is this outside electric field I'll be taking as epsilon, sorry, not epsilon, E epsilon I'll be taking, sorry, E naught I'll be taking, and then inside I will be taking it as just E in I'll be taking. Okay, that means inside this and outside outside area, all of this area. Okay, it is taken. Since it is just explanation of a concept, I'm just writing like this. You can just remember this. Always electric field that is outside of dielectric will be greater than electric field that is inside the dielectric. Okay, remember this point. Okay, so what is polarization? Polarization means arrangement, we can say. Polarization means arrangement. Polarization. I'm so tired now. By standing. I'm not such a strong body. My body is very weak. But even though I'm standing, that I can think that I will be giving as much as possible. But still, we haven't even jumped into NEET. We are still stuck with the outer surface area. We have to jump into the inner surface area of capacitance. Wow. Okay. See, first you'll be taking polarization of non-polar molecule. Okay, and then here polar molecule. So non-polar in sense, first in the very beginning it will be like this. Okay, and then electric fields will be there. C plus 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 minus 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 minus. So it will be converted into, this can be converted into, okay, C plus na, automatically negative part of this non-polar molecule will be attracted. So negative, and then here it is a negative. That means positive part of this molecule will be attracted. Like this will be. Okay, here also same. It is plus R. Here also it is plus R. So negative part will be attracted. Here it is negative R. So positive part will be attracted. Negative, positive. So like this it would have become. Okay. So for this, if you are checking out, the electric field intensity should be high. Electric field intensity must be high. Electric field intensity must be high comparatively to do this one. For this one, positive, 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 then a dielectric, positive, negative, negative, positive. Okay, like this it would have been like this. Also, I think I'm going to rub this one because, okay, yeah, it can be. It's not that bad. Okay, so now it would have become positive. It would have become like this. Negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive. Okay, like this it will become an electric field intensity should be greater for this one because here from non-polar molecule it has to be converted into polar molecule and then only it will be forming like this. Okay, but here it's not like that, just the arrangement of it. Okay, that is what their major differences. See, for non-polar, when no external field is applied to a dielectric with polar molecule, then the different permanent dipole are oriented randomly due to thermal agitation, so that total dipole moment is zero. Here, for non-polar molecule, it will be completely zero. The dipole moment is, but here it won't be zero for a polar molecule. Okay. Not bad. My legs are paining. Okay. So just remember this one point. Yeah, that's it. So we have successfully not completed this total topic. Now I'm just going to take this dielectrical, and I'm going to take. Okay, I'm going to take this one. So here it is completely positive in this side. Okay, and here it is completely negative in this side. That means negative charges will be attracted here from the molecule. Positive, 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 and positive. Okay, here also it will be same like that only. Negative, positive, negative, positive, negative, positive, negative, positive. like this. Now it would have become, yes, right, okay. So if I'm just segregating it like this from here to here, and from here to here it is being also segregated, then it will be here minus sigma charge, because we all know it is just negative. If you are taking here alone, okay, here will be plus sigma charge, there it will be minus sigma charge. Okay, and I have already see E. I have written now. When I was saying the concept, I said that E naught, EP, all of those things is right. Okay, so EP is actually E inside here. EP is actually E inside here. So here the total net electric charge, total E net is equal to E naught minus EP. We already discussed like this now, like this. So here electric field will be there, here electric field will be there now. So here I've written it as E in, right, here I've written as E naught, right. So instead of E in, here I'm taking E naught, EP, that's it. Okay, just know these concepts, that's it, because this will be helpful. This finally one point will be helpful. See, this polarization itself was not useful, completely useless topic, just like me in my home. Okay, one concept we are going to discuss. Okay, so polarizability is directly proportional to electric field intensity. See, if polarizability, that means to arrange them, you want a lot of polarization. Okay, that means the electric field will be also very high. So now, in order to make it just a formula, we have to apply a constant. Here, alpha is the constant, so E, and alpha is none other than here alpha is none other than molecular polarizability. Molecular polarizability, and here it's a SI unit is going to be alpha is equal to C m square voltage power minus 1. This is what it's SI unit is going to be. Okay, just a fun factor, if you don't know, just you can know, in a metal, if you're taking a metal, it can be any metal. In that one, if you want to know, just it can be asked as one mark question, maybe in the NEET examination. In a metal, approximately there are 10 to the power of 29 electrons will be there per unit. Okay, per unit volume. In per unit volume itself, that means in all the axes x, y, z, in all these axes, 1 meter, 1 meter, 1 meter, if you're taking, not 1 meter, I think 1 unit volume, no 1 meter, na. Okay, there itself there is 10 to the power of 29, there are 10 to the power of 9 electrons. Okay, now we will just stop everything by here itself. Oh god, I'm so done. I'm so done. Hereafter, I have no energy to stand. So this total capacitance topic we will stop by here. In the next video, we'll be talking about very important sums.